Okay, so we are on 1-7 and we are going to do mixture problems for this. I'm not going to go through all of them. I'm just going to do mixture problems, and that is all that you will be tested on. So let's go for quality instead of quantity. Instead of trying to learn how to do all of them, let's try to learn how to write the equations for just one of them, one of these types of problems. And your math lab in 1-7 and your weekly quiz will only include mixture problems. All right, so let's get this a little bit better focused in. And I want to talk first about to set these up, you've got to do your rate times your quantity. Okay, so that's first, rate times quantity. Like if you're getting paid $12 an hour and you're going to work for 3 hours, you know you're getting paid $36 because you have to do the rate of $12 per hour times the quantity of 3 hours, so you get 36 hours. Dollars, not hours, right? That's first. Second, it's a mixture problem. What are we doing with two things? We are mixing two different things together. So mixing mathematically means to add them, right? All right, so we're going to set up an equation where we take our rates and multiply them by our quantities and then solve for the ones we don't know. All right, Mike has coffee worth $4 per pound. So $4 is my rate. It does not give me how many pounds, so I know that's going to be a variable. To mix with 20 pounds of coffee worth $7. Okay, so I have this 20 pounds of coffee worth. So right there, just like my 12 times 3, I'm going to have 7 times 20. To get a mixture that can be sold for $5 per pound. So I don't know how many pounds of the $4, and I don't know how many pounds of the mixture. Those are what I'm going to have to figure out. But I do know that I am going to add $4 with my $4 coffee, with my $7 coffee, and that's going to equal to my $5 coffee, right? That's my basic problem. I do know that I've got 20 pounds of the $7 coffee. I don't know how many pounds of the 4, so I'm going to use my variable X. All right, so here's where you just got to do that reasoning it out kind of thing. This is my dollars, this is my dollars, this is my dollars. How many pounds are going to end up here? Well, I'm going to add 20 pounds and X pounds. So how much do I get if I'm going to do 20 and X? Well, that's 20 plus X, right? I don't know how much, but I do know that I'm going to do 20 of this and X of this, so that gives me a 20 plus X. All right, and that's all you need to get set up and going. Now you've got your equation written. So 4X plus 140, 7 times 20, equals 100 plus 5X, right? Subtract the 100 from both sides, and this is what you're going to do in whatever order you want. And I have 4X plus 40 equals 5X. And I'm going to subtract that 4X from both sides. and I've got X is equal to 40. So I have to do 40 pounds of the $4 coffee. Okay, and that's it. It's an addition problem. You're going to have to figure out what your unknowns are, but every term is going to consist of the rate times the quantity. Sometimes the rate is going to be a percentage. Sometimes the quantity is going to be pounds, gallons, hours. And mixture problems are always an addition problem. Okay. What was the other one we were going to do? Let's see. Let's talk about Frank here. Frank wants to mix 8 liters of 4% KCI solution with some 70% KCI solution to get a 50% KCI solution. All right, so what am I going to be adding in together here? I'm going to do a 4% plus a 70%, and that's going to equal a 50%. So there's my basic problem. Now, what quantities? These are all my rates. The percentages are going to be the rates. My 4%, I know I have 8 liters. So I'm going to go ahead, and you don't have to, but I'm going to change my percents into decimals. Plus 0.7 times X. Because I don't know. It says some 70%. So there's my variable. All right. So what about for my mix, my final mixture? What quantity am I going to have? I have 8 liters of 4%. I have X liters of 70%. So in my 50%, it's going to be 8 plus X. Okay? Then it's just to solve. Let's see. We've got 0.0432 plus 0.7x equals half of 8 is 4 plus 5/10 of x. All right, I'm going to subtract that 5/10 from both sides. Now I have 2/10 plus equals 4. And remember your decimals there. So when I subtract that 32, so I have 0.2x equals 368. Oh, let me get up here. That's just me solving. So 0.2, that is going to give me 18.4 liters of the 70%. Okay? Just remember, when it doesn't tell you how much your mixture, your final product, when it doesn't give you that quantity, it's just the sum of the two quantities that you're mixing together. Okay? All right, what if it does give you that? So let's look at a couple of other problems where it does tell you. And these we're going to work a little bit backwards. So let's go Sue here. All right. Sue plans to mix peppermints worth $1.20 per pound. So you see that $1.20 per pound. You know this is a rate. With chocolates that are worth $2.40 per pound to get a 40-pound mixture worth $1.65. Okay, so this time I'm not going to have this 8 plus X. I know my total for my mixture already. I know that my total for my mixture is going to be 40 pounds. So I am adding together my peppermints that are $1.20 plus my chocolate that's $2.40. And that's going to equal my mixture that's $1.65, and that's 40 pounds. All right, do I know how much chocolate? With chocolate's worth $2.40 per pound. Nope. So I'm going to put an X there. Now here's where you got to do that rationalizing. You got to figure this one out. If I have a total quantity of 40 pounds, I'm using X pounds here. How much is going to be left for my $1.20 peppermints? Because all I'm going to have is, all I got space for is 40 pounds. I'm using X pounds here. So what that's going to leave me for my peppermints is 40 minus the X. Okay? Because it told me the total mixture, the quantity for my mixture, I've got to use, I have the total quantity, so I've got to subtract instead of add. All right, so if I have $1.20 times 40, let's see, $1.20 times 40, I get 48. I'm distributing here. Minus 120x plus 240x equals, and I need 1.65 times 40, 66. And all I did was just multiply out what numbers I did have. And guys, if you wanted to put the 40 minus x on the 240, it don't matter. It does not matter which one you do. I tried to get with the cheaper one with the smaller rate so that my numbers stay positive, but it absolutely does not matter. All right. A negative 1, 2 and a positive 2, 4 gives me a positive 1.2x. There's my like terms. Plus 48 equals 66. Subtracting that 48 from both sides gives me an 18. So I have 1.2 times x equals 18. And I'm going to divide by that 1.2. X equals 15. All right, so my X was on the 240. So that's my chocolates, right? So I need 15 pounds of chocolate. And remember, my peppermints then were the 40 minus the X. So 40 minus the 15 is 25 pounds of peppermints. Okay, and the difference in the problems we did earlier and this problem was that we were given the total quantity of the mixture, right? So instead of having an X plus out here, we had a minus the X inside of the problem. Let's try to do one more. The sweet shop wishes to sell a special mix for Valentine's Day that consist of dark chocolate that costs $4 per pound. Not giving me any amount there. And milk chocolate that costs $2 per pound. Still, I don't have any amount. How much of each? How much of each? So I know I don't have the value for either of those quantities. 50-pound mix that consists of 260. All right. So I've got milk chocolate for $2 plus dark chocolate for $4. And that's going to be a mixture for 260, and that's 50 pounds. Again, I don't know what I don't know what the dark chocolate, how much quantity I'm going to need, so I'm going to put an X in there. I do know that the total is 50. So what is left? 50 minus X. All right. Now I'm just going to distribute, get my like terms together, and solve it. So 2 times 50 is 100 minus 2x plus 4x equals $2.60 times 50 gives me 130. So when I gather my like terms, I've got 2x plus 100 equals 130, and I'm down to a two-step. And I end up with 2x is equal to 30. Dividing by that 2, x equals 15. All right, so my x was on the 4. So I need 15 pounds of dark chocolate. And I've got a total of 50 pounds. So when I do that 50 minus my 15, I'm going to get 35. So 35 pounds of milk chocolate. Okay?